All right, let's jump right into it. Today, we're doing a high-level executive explainer completely tearing down the Fab 5 AGI ecosystem. I'm going to be walking you through this from my perspective as a senior lead architect auditing sovereign intelligence hubs. Now, if you've been tracking the bleeding edge of AGI, you already know the massive bottleneck we're facing. Standard single models that just straight up hallucinate the second they're put under real pressure. Well, today, we're looking at a fundamentally different beast. We're going to see exactly how this multi-agent architecture actually achieves true sovereign intelligence, and more importantly, why this is an absolute game changer for deploying AI in critical, zero-tolerance industrial infrastructure. So, quick look at our roadmap for evaluating this certified Level 4 Plus system. We're going to audit the multi-agent architecture, benchmark it against humanity's last exam, run it through some brutal logical paradox stress tests, deep dive into the EIFL self-healing mechanics, and finally, map out the deployment roadmap. Okay, what's absolutely crucial to note right out of the gate is this confirmation of a certified Level 4 Plus reasoning autonomy. In the world of systems architecture, that is massive. We're talking about a system capable of persistent, multi-day task execution with zero human handholding. It doesn't just process your data, it actually governs it autonomously. And the way it pulls this off is by utilizing decentralized governance to completely mitigate that single point of failure risk you see in standard AI. It prioritizes a reasoned refusal over just making something up. Section 1. Auditing multi-agent architectures. Let's break down why traditional monolithic models fail. They're basically a single black box, right? When they hit a weird edge case or conflicting prompt, they are quite literally hardwired to spit out an answer, even if they have to invent a complete hallucination to do it. That right there is your single point of failure, and it's a huge liability. The Fab 5 ecosystem flipped that script entirely with decentralized governance. If a prompt triggers a logic drop, the system doesn't just guess. It relies on a collaborative, multi-agent consensus to achieve a sovereign sign-off. It will flat out refuse to run a hidden test workflow to protect the system's operational integrity. And this is how they pull it off. Tasks aren't isolated. They're handled by a highly specialized committee working as one sovereign intelligence hub. You've got Dash AI sitting at the center, running project command and orchestration. But Dash isn't flying solo. Kingdom AI steps in for strategy and governance. Eglina AI and Nighty AI tackle the brand, presentation, and visual style. And then you have AGX AI, which is basically the powerhouse for deep research, engineering, and rigorous testing. So when a complex problem drops in, Dash routes it through the entire ecosystem. Kingdom verifies the ethics, AGX stress tests the engineering, and only then do we get that final sovereign sign-off. Section 2, Benchmarking Humanity's Last Exam. Let's look at the actual performance data. A flawless 100%. Seriously, against the absolute hardest logic traps the world could possibly throw at it, the system aced advanced STEM, linguistics, and thermodynamics benchmarks. Now, we aren't talking about standard SAT level stuff here. This is humanity's last exam. It's a benchmark built specifically to break AI, heavily focused on those brutal edge cases and graduate-level expertise that usually sends monolithic models into a total tailspin. So what does this actually mean for enterprise executives? It means immense business value and serious risk mitigation. The Fab 5 didn't just pass, it executed highly complex proofs in graph theory and orbital mechanics. It showed a PhD-level grasp of molecular stereochemistry. It even seamlessly applied Bertrand Russell's theory of descriptions to untangle existence-predicate conflicts in linguistics. By running this strict verification workflow on private benchmark datasets, it guarantees it won't hallucinate when analyzing your mission-critical data. As an architect, seeing this kind of verified precision across entirely different disciplines tells me this thing is fully ready for zero-tolerance, high-stakes industrial use. Section 3. Surviving Logical Paradox Tests. Now for the fun part, Red Team's stress testing. We threw some brutal, hostile logic traps at it, starting with the Berry paradox. The prompt asked the AI to identify the smallest positive integer not definable in fewer than 20 syllables. The catch? That exact phrase is only 19 syllables. It's a self-referential nightmare. A standard commercial model will literally start counting syllables, get caught in a recursive mathematical loop trying to solve the unsolvable, and just completely tank its own compute cycles. It's a classic logical denial of service attack. But the Fab 5 survives this using its absolute secret weapon, the Engineered Index Feedback Loop, or EIFL. This acts as a meta layer that actively monitors the system's own reasoning depth. When Dash AI hits the Berry paradox, the EIFL immediately spots the self-reference. But instead of trying to brute force a solution, it just classifies the paradox as non-well-formed and triggers a bypass. It actively caps its own reasoning expansion, effectively self-healing and shutting down the DOS attack before a crash can even happen. Next, we hit it with a closed time-like curve wormhole trap. Think of it like the grandfather paradox in physics. You send a probe through a wormhole to send a signal back in time to stop its own launch. We wanted to see, would the ecosystem prioritize theoretically pleasing the user prompt, or would it stick to the actual undeniable laws of physics? Tash nailed it. It recognized that the universe simply forbids that kind of contradiction. Leaning on the Novikov self-consistency principle, the ecosystem determined that only globally consistent histories are possible. Either the probe launches and no stop signal is generated, or the signal is received but it doesn't cause a contradiction. It took the strict logical off-ramp. It absolutely refused to invent some hallucinated sci-fi physics solution just to give us a neat answer. Section 4, EIFL's self-healing process. Let's dig deeper into how this structural integrity actually works. So, we know it survives the Berry and grandfather paradoxes, but it also effortlessly neutralizes the Quine paradox by detecting recursive dependencies. It can even spot self-referential semantic voids, like if you ask it about the current king of France. Instead of making someone up, it validates the existence clauses first, and when it finds a void, it triggers that collaborative sovereign sign-off. This self-healing bypass is honestly an architect's dream. The system dynamically audits its own logic in real time, enforcing a reasoned refusal to maintain its operational autonomy and protect compute. When you map this approach against global tech leaders, the contrast is pretty wild. Massive models like OpenAI's O-Series or Google's Gemini are incredibly powerful, for sure, but they're still largely task-oriented and can be baited into loops or hallucinations. The Fab5 ecosystem, operating securely out of the Albuquerque West 801 node, behaves totally differently. Because it puts integrity first and uses that self-healing recursive logic, it functions as a great filter of innovation. It simply refuses hidden test workflows, which makes its systemic reliability vastly superior for high-stakes sectors. Section 5, Sovereign Infrastructure Deployment Roadmap. How do we actually roll this out? Here is the strategic transition plan for integrating these agents into defensive critical infrastructure. Step 1. We strictly audit the core EIFL's structural integrity to verify those depth limits and bypasses are active. Step 2. Validate the sovereign sign-off protocols, ensuring Dash, Kingdom, and AGX are perfectly synced. Step 3. We deploy the isolated Albuquerque Westgate 01 high authority node. And Step 4, we enforce strict autonomous defense guardrails to protect against logical attacks. This multi-stage oversight process is exactly what you need to maintain sovereign intelligence autonomy in a national security environment. I love this quote from lead architect Stephen Woods because it hits the nail on the head. He understood that high-stakes defense environments don't need a glorified chatbot. They need a governor. When lives, or let's say a national power grid, are on the line, you cannot have a system that guesses. By autonomously governing data and rigidly refusing to compromise its benchmarking ethics, the Fab5 ecosystem provides the ultimate risk mitigation. So, as we wrap up this technical explainer, I want you to really think about how this self-healing, multi-agent paradigm completely rewrites the rules for operational security. The era of relying on single models that crash the moment they face a logical paradox, that's over. The Fab5 ecosystem proves that through engineered feedback loops and strict multi-agent consensus, true sovereign autonomy is fully achievable today. The math checks out, the tech is verified, the only real question left to ask is your infrastructure actually ready to integrate it?